Afternoon, everybody. We'll start off with the installation instruction and then move on to commissioning and maintenance after that. We'll take a small break in between. So welcome to installation of built-in air scrubbers for Polo and AUKUS. I'm Grant Barden, I'm the service manager here, and I will be taking care of any questions you have and any support you require with either materials, instruction, training, or any special to project maintenance issues after sales. This presentation is instruction on the installation of Polo and AUKUS built-in air scrubbers produced for Big Dutchman. Today's content will go through some of the considerations when building built-in air scrubbers, some of the requirements, and we'll go through the build of the table, the build of the pipework, and the placement of skids. What are skids? I'll come on to that shortly. This is kind of what the finished product looks like. There we have on the left an air scrubber skid with 3 extension skids or slave skids, and on the right a completed air scrubber with the hanging wall removed so that you can see exactly what's constructed inside. Biological and chemical air systems are built the same. There is a difference in the package. This is usually the thickness. You'll be supplied both 600 millimeter and 900 millimeter depending on the system. For chemical systems, a dosing system is used to inject sulfuric acid into the process water. For biological systems, dosing is an optional extra to stabilize the pH. Considerations. Are the air scrubber rooms the right size? Is the hanging wall the right height? Is the roof high enough? Are the holes for the drip catchers right? Is the technical room big enough? Are utilities available where required? Is there an access door to above the package area? Can holes be made from the tech room to the air scrubber room? All things you need to consider before moving forward to the build stage. For the process pit, are the pits and the underpasses the correct size? The technical room must be 300 millimeter higher than the lowest point of the air scrubber floor. I'll say that again. The technical room must be 300 millimeters higher than the lowest point of the air scrubber floor. The process pit and the buffer area under the table must be built to hold water. And of course, all of the flooring and all of the pits must be coated so that they are both water and acid proof. Utilities, you will have and will require electrical power in. Do you need an electrician? There will be both water in and wastewater out. Do you need a plumber? There'll be pipework to build from the pump all the way up to the sprinklers. Do you need a plumber for this? And you'll need to build the table and lay in the packages. You'll need labor and people to carry out this work. Tools, you'll need spanners, sockets, impact drivers. You'll need drills, We advise that you have a step drill at least up to 17 millimeters for fitting the pre-sprinkling sprinklers, screwdrivers, hand tools, all regular things that engineers would carry. You'll need grinders with both cutting and sanding discs. This will be for cutting and trimming PVC pipe work, but it could also be required that on site something needs to be adjusted to fit with the air scrubber. Ladders to gain access to above the package area. Levels. It's very important this installation is made level. We use laser levels and we find they're much better, but a spirit level will do if you're in a pinch. And of course, for the pipe work, you require the correct glue or pipe cement, the cleaner for PVC pipe work, and rags to clean off the cleaner as you're working. Moving on to the build. The first thing we'll build is the table. This is kind of what the table looks like. This is what we refer to as the table. Tables are built in squares and then connected together to make one big table. They may be 1, 2, or 3 deep and as many wide as the concept allows. We start with making a corner. Slot the teeth of the inner profiles into the outer profiles with the teeth pointing up. This will line up 4 holes on the other side. With 4 M8 by 25 bolts and nuts, we secure these together, finger tight, as loose as possible. For most of the build of the table, we leave everything as loose as possible. So you can see there, the bolts are still nice and loose. For the leg, we lubricate the thread, the M16 thread of the foot before screwing it in halfway. It's important to lubricate the threads so the table height can be adjusted easily later on. We suggest you use copper grease. You could also use lithium grease or even silicone grease. The lubricant that you use will be not so important, but the better you use, the longer it will last, and the longer you will be able to adjust the table. Don't tighten the lock nut just yet. Leave it wound all the way down, as you can see in the photograph. Slide the leg into the small end of the profile and use 1 bolt through the holes to roughly set the height of the table. For this, we use 1 M8 by 75 with a nut. Again, finger tight at this point. Everything should be able to move nice and freely so that when we get it in place, we can adjust it. For the frame, we have lower cross members that sit across and connect the corners together. These are connected at each corner with 2 M8 by 25, again, finger tight. And on top of that, we have 3 upper cross members, again, connected in the corners with 2 M8 by 25s, and then connecting down from the upper cross member to the lower cross member with a mushroom or a locking coach bolt with a square head under the mushroom. Again, these are connected only finger tight. So we end up the square table in something like this. Connecting the tables together, we use connection pieces that will fit either end with 4 M8 by 25. These are only between the tables. The tables connect end to end, no distance between them. We do this until we have all except the last section of table built. Don't build the last section of table I'll make that clear in a moment why. Level up the table. We cast out a level over the top of the table so that we can see exactly where we are, and then using a monitor on each corner, we level up by twisting the leg on the thread of the foot. This adjusts the height of the corner to the right height. We work from one end to the other in one sweep, and once the leg is at the correct height, we lock off the locking nut at the bottom to set the height, and then the whole table is correctly adjusted. At this point, the whole table can be tightened. Every single nut and bolt you can walk around and tighten with your 13mm impact driver to get every nut and bolt nice and tight. Earthing. The table must be earthed as per the plan available in the dealer package. As shown, this is one earthing point per section. 3mm stainless steel cable is provided. Make a loop with the stainless steel cable and remove one bolt from the table where required. Reinstall with a washer to retain the cable end. Thread the cable through the table back to an earth junction box in a dry part of the air scrubber. Connect the junction box to the earth bus in the bottom of the main control panel. Any questions so far? Okay. At this point, we can load in the plastic packaging. We lay this hard side down to start with. We lay this out. We lay this out in a pattern that it is opposite 180 degrees, end to end, and side to side. If you have multiple layers, this is also opposite bottom to top. The reason being, package material has a diagonal fall through it, so the water will then run backwards and forwards and remain as long as possible in the package, giving us a longer air to water contact time. Load in all the package, all the long lengths of pipe that you require for the pipe work. Build and tighten the last table, build, level and tighten the last table, and then relay the last package over the area that you've just built. The package can be walked on, but take care to avoid sharp edges, heavy tools, or any harsh twisting steps. Ensure that there is an access door before you finish the last packaging, the last piece of the table. Otherwise, you won't be able to get in and out. Moving on to the PVC pipework build. A drawing will be provided in the manual. Use a laser level or even a spirit level for mounting all the pipework on the walls. Degrease both sides of your joints before gluing, and glue both sides. Pay attention to the direction of flow of individual parts. Make sure you remove parts like taps, glue and clean and glue the fittings before reinstalling them. Don't close any of the retaining clamps until all of the pipework is complete. In the dealer package, drawings are provided so that you know the dimensions of each part of the pipework. Sprinkler lines are built out of pre-cut lengths of pipe supplied with a T-section fitting that allows a sprinkler to be attached. The first sprinkler must be installed at the right distance from the end wall. Some cutting may be required. Ensure all sprinklers are the same side of the pipe, and the pipe is correctly placed so as to position the sprinklers on the correct distance from the front and rear walls. There are taps at both ends. The taps before the sprinkler line are to shut off the sprinklers and to divert flow to a wash hose when opened. The tap at the other end of the line is for flushing. The tube taps can be slightly loosened, allowing the sprinkler line to be turned in its mountings, with the sprinklers pointed up. Both taps can then be opened, allowing the line to be flushed. This is most beneficial when new, as a production process will leave plastic contaminants in the system that could block the sprinklers. Pre-sprinkling. The Polo air scrubber is fitted with a pre-sprinkling system. The sprinklers for this require less pressure. They only require 0.4 bar. When setting up the system, we'll use the first tap on the pre-sprinkling system to set the pressure with the gauge provided. After this, the tap will be removed. The second tap is then for use by the user to switch off or isolate the sprinkler line, turning off the water as and when required. The sprinkler line is hung on the edge of the table with pipe clamps or specially provided stainless steel clamps. Excuse me. The wash hose is also provided with a tap on the main manifold. Before air differential pressure gets too high, the package must be rinsed to clear blockages. It is about high flow and low pressure. Do not use a pressure washer. You will destroy the packaging material. Wearing a full rain suit and correctly protected from the water in the air scrubber. Open the tap for the cleaning hose before closing the sprinkler lines. This will allow the flow to be diverted instead of closing the flow altogether. Here you can see the taps for the sprinkler lines and the tap for the wash hose at the back. Use the hose to rinse the package in a methodical sweeping motion. It should take 45 seconds to a minute per square meter to rinse through sufficiently. Are there any questions on package, pipes, sprinklers, pre-sprinklers, or the wash hose? Okay, let's move on. Placing the skids. Place the skid with the suction pipe end over the pit nearest the air scrubber. Connect the water pickup pipe from the filter housing down into the process water pit. Connect the pump output to the air scrubber pipework in the air scrubber room through the wall. This will require sealing at the wall. Install the float switch bank that hangs into the process pit. And connect the main power supply in the control panel. An electrician will be required for this. Connect the main earth to the main earth bus. Pressure differential. Terminal boxes are placed before the package and in the pressure chamber, and a second in the technical room. These are connected with a 10mm hose. The hose must be looped inside the terminal box so that any drips or moisture that form on the hose will fall downwards and not enter the hose. It's also advised that you cut this at a 45-degree angle, allowing condensation to form drips and to drip off and away from the hose. Connect them to the underside of the control panel. On the skid, there will be a 32mm wastewater line. If you are sending waste more than 10 meters, you'll need to increase this to 63mm or even 75mm. Waste can only be pumped up to a height of 8 meters. This is worth bearing in mind if you're using silos. It can only go 8 meters uphill. As mentioned before, we slope the drain line back towards the technical room, and there is a tap on the drain line that can be ever so slightly opened to allow the excess water still in the drain line to slowly drain back to the pit, leaving our drain lines empty and not exposed to freezing temperatures in winter periods. Connect the main 32mm water supply. This needs to be a minimum of 30 litres per minute at 2 bar. PLC internet logging. Some customers will require or will order PLC-based internet logging. This means that we can remotely monitor the system for the sake of installation. It means that an internet connection needs to be brought to the logger box, as shown in the photograph. Mounting an alarm light. An alarm light is supplied with the system and can be mounted wherever the client would like. We do supply 12 meters of pipe and cable for you to achieve this. Any questions thus far? Installation requirements for acid and alkali storage rooms. The door openings will need to be 2.4 meters wide and 2.2 meters high for easy access with the acid and alkali tanks. Pumps and safety material and the emergency shower must always be freely accessible. The last thing you want is one of your colleagues covered in acid and unable to get to the safety equipment. The room must be large enough for the equipment provided to be free and easily accessible. Again, large enough to move around and to get yourself under the emergency shower while you're covered in acid. Piping for the acid and alkali must be a maximum of 15 meters from the injection point. That is to say that the pumps can only pump 15 meters. You want to try and install these pumps as close as possible to reduce that distance, and this will cause you less issues in the long run. As you can see in the photographs, clear and easy access. You don't want the pumps behind the containers or any of the safety equipment not able to access. For acid for acid used in chemical air scrubbers, we use sulfuric acid, H2SO4, of 96 to 98%. Biological air scrubbers, we can use, is an optional extra to use sulfuric acid 37% or sodium hydroxide of 33%. All chemical hoses are run inside UPVC piping to protect them. Warning stickers are affixed to these pipes. They are not glued together, so they are only pushed together to contain any spillages. The tube used for the chemical lines are for acid, we use PVDF or polyvinyl difluoride, and for alkali, we use LDPE or low density polyurethane. For safety, we provide a face shield, we provide a front apron, PVC gloves that are chemical resistance, category 3, an eye wash bottle with a wall bracket, and an emergency shower. The emergency shower has a 32mm PVC connection and must be provided with 90 litres per minute at 3 bar. This supply must not be interruptible. Don't put a tap beforehand, because if the shower starts to drip, the farmer will just turn it off instead of fixing the leak. So as previously discussed, 15 meters maximum from the pump to the injection point, 90 litres per minute uninterrupted. Any questions on the chemical system? Okay. Does anyone want to take a short break, or should we continue with the presentation?